Here's a clear explanation. And before I do part A, again, I want to show you what part B means. Whenever you see plus pi over 2, plus pi over 2 means add 90 degrees to, and whenever you see theta like that, it just means add 90 degrees to the triangle. And when you see a P like that, it means they want to know the point when we add 90 radians, pi over 2 radians, 90 degrees, to that particular angle. So let me show you visually what that means. No matter what triangle I draw here, let's draw a low one so it's visually more accurate. We can see that I have drawn this triangle. It's against the x-axis, and the mysterious missing angle theta would be right here, right? Be right there. And that theta has a distance here, x1, or just x, and it has a height, y, which means the coordinates here correspond to the length and the height. X comma 1. Now keep in mind we're talking about a unit circle, 1, with a hypotenuse of 1, which means the sine of this angle is equal to the opposite, y, over the hypotenuse 1. Or in other words, any angle in a unit circle, the sine of theta is equal simply to the opposite side, which happens to be the y values. And the cosine of theta is equal to the adjacent over hypotenuse. Hypotenuse is 1 in this case, and adjacent happens to be the x values. So the cos of theta of any unit circle is equal to the x value, which is why if we find the x and the y values, we are essentially finding the value of cos theta there and y theta here, and it's why the opposite is the same as y. It's why you can do it. Now, what's interesting is x and y is positive and negative, which explains why in this case the adjacent is cos. Well, the adjacent would be negative. Therefore the cos would be negative in this quadrant because the x values here are negative. But I just want to focus on the fact that it has x and y. Now if I take this same triangle and I rotate it 90 degrees, I add 90 degrees to theta, which is counterclockwise in the unit circle. I'm going to rotate it left 90 degrees, and I'm going to fit it on my unit circle. It's clear it still touches the unit circle on the perimeter, but it's also clear what used to be the y here is now the x here. Is now the x here. Right? That height, the same height that was y, is now going along the x-axis. The length here that used to be x over here that I've rotated downwards is now going along the y-axis. So it's clear that this point here is the same digits as there and there because it shares the same dimensions of the triangle. But it's clear the x and the y have swapped. It's also clear that I'm in this quadrant now. So x is still negative. So the x will have the same value. But the y, which was positive in quadrant 2, will be negative. So that means the coordinates here, and I won't include the minus, whatever coordinates were here will be the same coordinates here, except the y will be the negative value of that one. Oh, actually the negative value, let me rewrite that. It will actually be the negative, still be the value of y, will be the value of x down here is the value of y up top, and the value of x is the value of and the value of y down here is the same value as x up top. And the x up top was negative, which is fine, but the y value is down here, which is now the x value, has to be negative. And that's because up here the x value is negative and the y value is positive. Since the y became the x values here are negative, we have to take the negative x. In other words, if I was to use actual points here, let's say it was 0.5 and 0.86, right? the 0.5 here would be negative because we're in that quadrant. Down here, the values would be negative 0.86, the y value up above but made negative, and negative 0.5. And that's because the dimensional triangle has been flipped on its side. Now notice I can do the same thing with the dimensional triangle if I flip it the other direction. And rotate it to the right 90 degrees. And put it here. It's going to have what used to be the x, y values over here are now going to be, the point here is now going to be 0.86 and 0.5. Both are going to be positive because I'm in quadrant 1. And finally, if I rotate the triangle 180 degrees, right? Rotate it 180. It's going to appear over here. And it's going to share the same x value, x, y values, but opposite signs. So down here it's going to be negative 0.5 and negative 0.8. Or sorry, positive 0.5 because it's now in quadrant 4, and negative 8.86, the same numerical values but the opposite signs. And that makes perfect sense when you visually do it with these triangles because you can see the triangle dimensions have swapped places on the x and the y axis. Good. That means we know when we do find this point up here, if we add, and it's over here in this quadrant, this point is clearly in the 4th quadrant because they told us. So we're going to ignore this point, but we're going to leave this triangle up here. We're going to get rid of these triangles over here because they're no longer relevant. And we're going to go get rid of these triangles down here because they're no longer relevant to this question. But now we understand the concept. It means whatever x, y value I find here, and I know one of the x values is going to be 15 over 7 because they've told us it is, 15 over 17. The y value is going to be negative something. We don't know what. But up here, they're going to swap. And they're going to be positive because we're in quadrant 1 now. So it's going to be the positive version of the question mark. But it's still going to be 15, 17 over here. I can even answer this part here. What is the sign? Because now the triangle that I have to build to determine the sign has to be between here and the x-axis. I'm not allowed to build to evaluate cosine. Sorry. Yeah, I'm not allowed to evaluate sine unless I build the triangle against the x-axis. Well, I can see that this is the angle theta plus, this is the angle theta plus pi over 2 now. Even though it's really, it's over there, we have to measure against the x-axis. This is angle theta pi plus pi over 2. And the sine of it is the opposite over the hypotenuse. The hypotenuse is still 1. The opposite is that value. So I can even answer that without getting into this question. The sine of theta, I'll just use x, plus pi over 2, is equal to the y value. It has to be because we're measuring against the x-axis always. And yes, even though this angle here is rotated there, the sine of that angle is always measured against the x-axis. So this is the triangle we're actually measuring. Now, and it still is 90 degrees, right? That went from there to there is 90 degrees. Now to answer the coordinates, we can still use this rough black triangle because we can see that they gave you the x values. They gave you the x values. And we did this together, I know already. But they gave you the x values right here, 15 over 17. They also give you the hypotenuse because they tell you it's a unit circle. Hypotenuse is 1. So we can easily figure out b, since x squared plus y squared is equal to 1 in this case. That's the formula of the unit circle, which we can also see from our graphing calculator. X squared plus y squared is equal to 1 creates the unit square circle. And we know x squared is 15, and you and I did this already, I know, over 17 squared. And we know that ends up being 225 over, what was it, 289? I think, memory serves. So that means 225 over 289 plus our mysterious y squared is equal to 1. I subtract it from both sides. 1 minus that. And of course we determined it was 64 over 289. We take a square root of both sides. We get 8 over 17. Now, the interesting thing about taking a square root, when I solve this, when I determine that y squared is equal to 225 over 289, when you take the square root of both sides of any situation, you have to add a plus minus. And that's because the square root of 9 can be both 3 and minus 3. And the reason that's true is because the square of minus 3 is still 9. And when you square a negative number, it ends up being positive. So square root of 9 has two possible answers. So when we take a square root of this, we get plus or minus 8 over 17, which makes sense because this angle exists over here, it exists up here, it exists over here and over here. So it's accounting for all possible y values. In this case, we know we're in quadrant 4, so we know the y value is negative. So the y value is negative 8 over 17. And that means this point here is P, 15 over 17, comma, negative 8 over 17. Now, when we rotate it, the x and the y swap, and the rotated triangle is clearly, let's just do that and see if I can, if I can rotate it. I'll flip on the vertical and the horizontal. So when I rotate that triangle 90 degrees left, which is what you do when you add pi over 2, we can see that the x, y coordinates swapped and are both positive because we're in quadrant 1 now. So that means the coordinates swapped, if I add 90 degrees to it, the new point is positive 8 over 17, comma, positive 15 over 17. That's the new point. And since sine of this new angle is equal to y, then sine of this new angle, x plus pi over 2, is equal to 15 over 17. There, I think that's a clear explanation.